Good evening, everyone. Guys, am I audible? Yeah, thank you. So, for today, let us discuss about how we can establish secure communications between multiple networks. So, what we have been doing so far with either the ASA firewall or maybe with the Storm Shield UTM is we have a network, right? So, we have an organization network, and when this organization network resources, maybe their LAN computers or the servers, have to be connected with internet. We have seen how do we connect those resources with internet, what kind of policies do we write for outgoing traffic as well as incoming traffic and all, right? Now today let us say, instead of only one office, assume my organization, they have a requirement to communicate with multiple locations. Now, let's say I have a head office and I have a branch, right? Or maybe this is my office and the other is a client network, right? So here I have a requirement that I have to connect from my office to my branch, or maybe the resources which I have hosted in my office have to be accessible to people in my branch or maybe people in my client network. So, can I use either static NAT or port redirection NAT? Can I use either static NAT or port redirection NAT and give the public IP address to my branch or maybe give the public IP address to my client so that they can access my servers, they can access my resources? Can we do that? So I have some servers, I have some resources in my office. I want my client or I want my branch office people to access those servers, right? So can I use static NAT or port redirection NAT, give them the IP address and ask them to access those resources through the IP? Guys, can you hear me? So did you guys understand what I'm asking? What is my question? So if I have some servers or have some resources in my office, and I want my branch office or maybe my client network people to access those resources, can I configure static NAT or port redirection NAT for those servers and ask my branch office people or ask my client to access those resources from internet? Can I do it or not? Okay, so if you have some resources, right, that you want your branch or maybe your client to access, right, you will be able to configure static NAT or port redirection NAT, share the IP address to your client, ask them to access the resources, right? Similar to how you are doing a static NAT for hosting the website or hosting your remote desktop servers and all, the same fashion. But the main challenge here is, as long as you are trying to share some public resources like a simple web page or something, not an issue. But if you want to exchange some confidential data, then you will not be able to do it through internet, right? So trying to exchange confidential data through internet is not recommended, right? So in such condition, you will need a secure communication. You will need a secure channel between your head office and the branch office, right? So between the head office and the branch office, you will require a secure communication channel, right? So to enable this secure communication channel, we use something called VPN, virtual private networks. We use something called VPNs, virtual private networks. So in VPN, there are different technologies. The most commonly used ones are IPsec VPN and SSL VPN. So the most commonly used VPN technologies today are IPsec VPN and SSL VPN. Right. So we'll first discuss about IPsec VPN, then we'll do the configuration for the SSL VPN part. Right. So here, when you speak about the IPsec VPN, IPsec VPN is a open standard framework, right? So IPsec VPN is a open standard framework. So there's nothing like it is only available in some specific branded devices or something, right? So IPsec VPN is available on any device which can handle layer 3 traffic. So IPsec VPN is a layer 3 communication framework, right? So any device which can handle layer 3 traffic will be able to give you this IPsec functionality, right? Except for your L3 switch, right? So every device which handles layer 3 can work with IPsec VPN. Like say, you can configure it between a router, can configure it on a firewall, a UTM device, a PC, or maybe a server, right? So you'll be able to configure it on all these devices except the layer 3 switch or your multi-layer switch. And as I said, this is a open standard. I can have this configured between, say, a Juniper router and a Cisco firewall, or maybe between a Cisco firewall and a Storm Shield UTM, right? So I can configure this IPsec VPN between any of the devices which are supporting this IPsec VPN standard, right? So here, as per my example, I have a head office, let's say in Hyderabad, and I have a branch, say somewhere in Delhi. I have a head office for my organization in Hyderabad and I have a branch in Delhi. Now, my requirement is to enable secure communication between these two networks. Right. I want to have a secure communication between these two networks using VPN. Right. Now, the first requirement for us to configure a VPN is both the networks should be connecting to internet. So the first requirement is both these networks, your Hyderabad network as well as your Delhi network, have to be connected to internet. Right? So internet is a minimum requirement. Without internet, you will not go with the VPN configuration. So internet is anyway available in both the networks, right? So today, every organization you have internet connectivity there, right? So once you have internet available on both networks, then you have to start configuring VPN on the gateway device. So you need to have a gateway device which supports IPsec VPN. So any of these device types will be suitable, right? So any of the device types which can handle IPsec VPN will be suitable. So that's a second requirement. So now let us say if I have to send some secure data, or I have to securely send some data between, say, the Hyderabad and Delhi network, I'm sending it through internet, right? So whatever data I'm trying to send from my Hyderabad office to the Delhi office, or maybe from Delhi office to the Hyderabad office, I have to send everything through internet. And as you all know, when you're trying to send some data through internet, obviously there is a chance that someone can capture your data and view what exactly is being transmitted, right? So you have a chance someone can capture the data and see what exactly you are trying to exchange. To prevent this, what IPsec VPN says, it gives you an option to encrypt all the data. So whatever data you are trying to exchange can be encrypted. Right, so it is giving you with the encryption option. Again, there are two different type of encryption methods that are given in this IPsec VPN. One is authentication header, and the other is encapsulating security payload. So there are two different type of authentication methods which are given by IPsec VPN: authentication header and encapsulating security payload. So when you go with the authentication header, or AH, this is how your packet would be encrypted in AH. Say you're sending data from Hyderabad device to Delhi device. Some data is being sent. So in the AH, high level encryption will be used to encrypt your source and the destination part, and a basic encryption, right? A basic encryption will be used for encrypting the data part. High level encryption will be used for encrypting the source and destination, and a basic encryption to encrypt your data part, right? In ESP, that's different. In ESP, for the same kind of data that is exchanged from, say, Hyderabad to Delhi device, high level data encryption is done on the data part and no encryption for the source and destination part. So there is no encryption for the source and destination, but high level encryption is provided for the data part. This is in ESP, encapsulating security payload. In AH, authentication header, high level encryption is provided for the source and the destination fields, and basic encryption is provided for your data part, right? So here, as you see, AH seems to be encrypting the entire packet. The full packet is encrypted in AH, and ESP is only encrypting the data part. But here, if we observe, our priority is to have secure data communication, right? So our priority is to have secure data communication, right? So here, instead of AH, ESP, which is giving high level encryption for the data part, is a better choice. Instead of AH, ESP is a better choice, right? So ESP is giving you high level encryption for the data part. So that would be a better choice compared to AH. And we always use ESP when you are performing VPN configurations, right? So when you are using VPN, instead of AH, it is ESP which is used, right? Now, at the same time, when you speak about the data encryptions using ESP, when we speak about data encryption, right, your data has to be converted from clear text format to some unknown format. Your data has to be converted from clear text format to some unknown format in the encryption part. And for this encryption, again, there are two different mechanisms, right? So one mechanism is symmetric key exchange method. Right? So one method is symmetric key exchange method. So in symmetric key exchange method, same password will be used for encryption as well as decryption. It's the same password that will be used for encryption as well as decryption, right? So here, let's say you're trying to send some data from the Hyderabad network to Delhi network. This is how your data packet looks like. Source is Hyderabad, destination is Delhi. You have some data, right? Now this data part has to be encrypted. Now, because Hyderabad is a source, right? Hyderabad will do the encryption and the Delhi device has to perform the decryption, right? So let's say Hyderabad is using encryption key ABC123. It is using a encryption key ABC123. Right? So once the data has been encrypted and sent to Delhi, Delhi is supposed to do the decryption. But the problem here is Delhi device does not know what is the encryption key used by the Hyderabad device. Right? Delhi device does not know what is the encryption key used by the Hyderabad device. So here, for this Delhi device to decrypt the data successfully, even before data has been encrypted and shared, right? Even before data has been encrypted and shared, both the Hyderabad device and the Delhi device have to exchange this encryption key. So the Hyderabad device has to say that I'm going to use a encryption key ABC123, and the Delhi device should also say, okay, I'll also go with the same encryption key ABC123. Right. So the Hyderabad device and Delhi device have to exchange the encryption keys. Right. Hyderabad device has to tell the Delhi device that I'm going to use ABC123 as my encryption key. And the Delhi device will also say, yes, I'm using ABC123 as a decryption key also. Right. Now the problem here is in this particular exchange method, if we assume there's a hacker who is trying to capture traffic between Hyderabad and Delhi, this hacker will be able to see what is the encryption key used by these two devices, because the encryption key itself is being exchanged, right? Hacker can see what is the encryption key used by this device, right? and this would actually compromise our security, because once a hacker knows what encryption key is being used, hacker can also decrypt that particular packet and view the data. So whatever data we are encrypting and sharing over internet can be decrypted by the hacker. Right. So even though this method, symmetric key exchange method, is giving us encryption capabilities, it's not providing us with the required security. It is not providing us with the required security, right? So we do not use this method, right? We do not use this method for encrypting our data in the VPN, right? But as an alternate, instead of symmetric key exchange method, we use something called asymmetric key exchange. So we use something called asymmetric key exchange method. In asymmetric key exchange method, what happens? The administrators of this Hyderabad network and the Delhi network have to communicate to each other and decide a common encryption key. Right. The administrator of Hyderabad network and the Delhi network have to communicate to each other. Maybe they can communicate through emails or phones or some other means, right? Communicate to each other and decide what should be the encryption key. Now, let's say the administrators have decided encryption key is going to be ABC123. So this ABC123, or the encryption key, which is decided by the administrators of both Hyderabad and Delhi networks, we call this as pre-shared key or PSK. We call this as pre-shared key or PSK. Right. So once the pre-shared key is decided, it will be defined or it will be configured on both the devices, on the Hyderabad device as well as on the Delhi device. The pre-shared key or the PSK will be configured. So once the PSK is configured here, within your device, within your gateway device, it can be a router, it can be a firewall or a UTM, right? Within your gateway device, you have a framework called Internet Key Exchange, IKE. So there's a framework within your device called Internet Key Exchange, IKE. Now what this IKE does, it will take the pre-shared key, add some random data to it, right? It will take the pre-shared key and add some random data to it. And on this combination of the pre-shared key and random data, on this combination of the pre-shared key and random data, IKE will run Diffie-Hellman algorithm. IKE will execute Diffie-Hellman algorithm on the combination of pre-shared key and some random data. Now this Diffie-Hellman algorithm will generate two passwords. Diffie-Hellman algorithm on this combination will generate two passwords. We call one password as a public key and the other password as a private key. Right. We call one password as a public key and the other as a private key. Right. So once this public and private keys are generated by IKE, then both the gateway devices, the Hyderabad gateway device and also the Delhi gateway device, they both have two passwords each. You'll have public key of Delhi, private key of Delhi, And the Hyderabad device also will have its own public and private key. It will have public key of Hyderabad and private key of Hyderabad. So public key of Hyderabad and private key of Hyderabad on the Hyderabad device. Public key of Delhi and private key of Delhi on the Delhi device. Right. So you have a set of public and private keys on both devices. So once you have this public and private keys here, both the devices will exchange their public keys. Hyderabad device will give its public key to Delhi device, and Delhi device will share its public key to Hyderabad device. So here in short, the public keys are exchanged. Right. And if you see, only the public keys are exchanged, not the private keys. Right. Only the public keys are exchanged, not the private key. So even if you consider there is a hacker who is capturing all the traffic here in between, hacker will only see the public keys which are exchanged. Hacker will not see the private keys. Hacker will only be able to see the public keys of both the Hyderabad gateway and also the Delhi gateway. Right. And once the public keys are exchanged, then your gateway devices can start encrypting the data and exchange it on internet. Now let's say for example, Hyderabad device has to exchange some data with the Delhi network. Right. So data is now being exchanged by the Hyderabad network to Delhi network. So here encryption will be done by this Hyderabad gateway device. Hyderabad gateway device has to perform the data encryption, and it uses public key of Delhi to perform this encryption. Right. The Hyderabad device will use public key of Delhi to perform the encryption. Right. It's using public key of Delhi to perform the encryption. Right. So that once the data has been delivered, right, once the data is received by the Delhi device can use its private key to decrypt the data. Right. So the source will encrypt the data using the public key of destination. Destination device will perform decryption using its own private key. Right. So generating this public keys, exchanging the public keys, and then encrypting your data with the public key of the destination device, right? This is all considered as phase one of your VPN. You also call it as IKE phase, right? So this is called as IKE phase or phase one of the VPN. Once phase one is successful, once your gateway devices are successful in generating the public and private keys, exchanging the public keys and all, right, then you go with the second phase, phase two, or you also call it as IPsec phase. Phase two or IPsec phase. So in phase two or IPsec phase, here you will start communication between the local network resources of Hyderabad network to local network resources of Delhi network. So in short, the LAN computers in Hyderabad network and LAN computers in Delhi network will communicate in phase 2. So let's say uh, Hyderabad network has 192.168.10.0 as a network, and Delhi has 192.168.20.0 as a network, right? So Hyderabad has 10.0 as a network and Delhi has 20.0 as the network, right? And here if you observe, the LAN network on Hyderabad and LAN network on Delhi are two different subnets, right? So they are not the same subnet, they are different subnets, right? This is another requirement that you have to keep in mind, right? So whatever LAN network you have, right, should be belonging to different subnets, right? So you cannot have LAN network of the same subnet on both the ends. Okay, so here, now let's say I want one of my LAN computer in Hyderabad network to communicate with another LAN computer in Delhi network. Let's say there's a request coming from 192.168.10.10 trying to reach 192.168.20.10. There's a request from 192.168.10.10 trying to communicate with 192.168.20.10. Here if you observe, both the source and the destination IP addresses, right? The source and destination IP addresses both are private IPs, right? Source and destination both are private IP addresses. Now the problem here is with source and destination as a private IP, we will not be able to forward this packet to internet. We cannot send this packet to internet with source and destination as private IP. So what we will do, instead of forwarding this packet as it is, we will add new IP headers to this packet. So in short, we are going to encapsulate this packet with a new IP header. So the new IP header will be like source public IP address of the Hyderabad device, destination public IP address of the Delhi device. Right. Source public IP of Hyderabad device and destination as public IP of the Delhi device. Now if we see this, the outer layer, this looks similar to your phase 1 packet. This is looking similar to your phase 1 packet, right? And according to ESP or encapsulating security payload, we have to perform encryption on the data part, right? So this will be encrypted using public key of Delhi, as we have already discussed. Right? We'll be using public key of Delhi for the data encryption. And for the inside packet, traffic which is initiated from 10.10 to 20.10, this packet also should be encrypted according to ESP encryption standards. Right. According to ESP encryption standard, you should also encrypt the inside packet. Now for this inside packet, you can either use pre-shared key for encryptions, or you can use the private key of source. You can use either the pre-shared key or the private key of the source for encryption. So always remember, for the outer packet, right, you are using public key of the destination for encryption. For the inside packet, you will either use the pre-shared key, the common password, or you will use the private key of the source, for encryption, right? So this is what happens in the phase one and phase two, right? So phase one, communication between your gateway device to the remote network gateway device. Phase two, communication from one of your LAN system to the remote network LAN system. Right? So only once this phase one and phase two are successful, you can say your VPN is established and your communication will be successful. Right? If phase one and phase two are not successful, they have not established, your VPN communication will not be successful. So your LAN computer will not be able to communicate with the remote network LAN computer. Right? So for your IPsec VPN, both phase one and phase two should establish successfully. Right? So this method, where you are creating a VPN between two different locations, you call it as site to site VPN. You call it as site to site VPN, right? So this is VPN created between two different locations. Right? VPN created between two different locations. You call it as site to site VPN. Now, when you speak about this IPsec VPN, it is not only defining encryption, it also says you have to perform a hash value calculation on whatever data that you are trying to exchange, right? So on whatever data you are trying to exchange between these two networks, you should also perform hash value calculations. The reason why hash value calculations are to be done is when you are exchanging the data over internet, there is a chance that some packets might be lost in the transmission, right? So the destination device should be able to see if it has received all the packets or not. Now, let's say, for example, the Hyderabad device has sent 100 packets, right, of data. Now, Delhi device should be able to see if it has received all the data or not. So, if it has received all the 100 packets or not, right? So, to check that whether it has received all the data or is some data lost in the transmission, right? Integrity checks have to be performed. So, for integrity check, hash values are required, right? So, IPsec VPN says you can use hash values for data integrity check, right? And for protecting the data and for data protection, when you are transferring it on internet, you have to go with encryptions, right? So encryptions for data protection, hash values for data integrity checks, right? And when you speak about this encryption keys, your public and private keys, which are generated by IKE, so these public and private keys are not permanent in nature, right? So they are not permanent in nature. This public and private keys will be valid only for some duration, right? So after that time, after that particular duration, public and private keys have to be regenerated, right? In the same way, your firewalls also have to keep on checking if the phase one and phase two parameters are all same or not. Your firewall or your router, whatever the gateway device that is participating in the VPN, has to constantly keep checking if all the VPN parameters are same or is there any change, right? So the time period, how frequently this public and private keys are generated and how frequently your VPN settings are verified, that particular time period is called SA lifetime, Security Association lifetime. You call it as SA lifetime, Security Association lifetime, right? Now you will have SA lifetime for phase one and also for phase two. So you'll have SA lifetime for both phase one and phase two. So here for phase one, SA lifetime on ASA firewall is 24 hours. On Storm Shield, it is 6 hours. Phase 2 on ASA firewall, the SA lifetime for phase 2 is 8 hours. On Storm Shield, it is 1 hour. Now, if you observe, the phase 1 and phase 2 SA lifetimes are not same on ASA and Storm Shield. So this is one challenge that you have to resolve. And also the kind of encryption methods and hash methods along with the Diffie-Hellman algorithm, right, will also be different, right? So Diffie-Hellman algorithm can generate public and private keys anywhere between 1024 bit to 4096 bit, right? So you have to make sure that on both the gateway devices, your public and private keys are of the same bit length. Let's say, for example, if ASA says I'll generate a 1024-bit encryption key, right? And Storm Shield says I'm trying to create a 2048-bit encryption key. Then your encryptions will not be successful, right? So whatever encryption keys that are being generated should be of the same bit length on both the gateway devices. Whatever encryption method is used should be the same, right? So I cannot say on ASA firewall I'll use encryption something as AES, and on Storm Shield I'll use something like DES. So I cannot go with different kind of encryption algorithms. So same encryption algorithm has to be used. Same hash value has to be used, right? So these all parameters have to be taken care of when you are creating a VPN tunnel between two different type of devices. If you are creating a VPN between, say, ASA to ASA, things will be much simple, right? Or you are creating a VPN between, say, Storm Shield to Storm Shield, things will be much simple because you'll not have any parameters to verify. Everything will be of the same parameter type, so no issue, right? But when you speak about VPNs between two different vendor devices, there you'll have to consider all the parameters, your encryption methods, your hash methods, SA lifetime, and all these things. So you'll have to make sure that they are all same on both the devices. Only then VPN will establish successfully. If not, your VPN will not establish, right? So we'll see how exactly this VPN will be configured, the IPsec site-to-site VPN, how exactly we configure it between ASA and Storm Shield. Right. Okay, so first I will do the configuration in ASA firewall, and then I'll do it on the Storm Shield UTM. Right. So to start configuring VPNs, we'll connect to Storm Shield using, sorry, we'll connect to ASA using its LAN IP address. Okay, so here these are the networks on ASA firewall. On the LAN network, I have 192.168.20.0/24. Public IP is 206.182.202.122. On the Storm Shield side, I have 192.168.10.0 as a LAN network, and the public IP on the WAN interface is 201.122. Right. So this is how I have the LAN and WAN IP addresses. Right. So now we will start the configuration for this site-to-site VPN, we'll see what all parameters have to be configured and how we'll have to do that. So on the ASA firewall, once you are connected to ASDM, you can go to wizard and say VPN site-to-site wizard. So you have to say site-to-site VPN wizard, right? So it will start a configuration wizard for the site-to-site VPN. So all you need to do is just go through the wizard and it will do the configurations. So start the configuration. It is now asking you what is the peer IP address. So when you say what is a peer IP address, so we are configuring this on ASA firewall. So the peer IP address is the public IP address of the other device, right? It's a public IP address of the other device, right? So I say the peer IP address is 206.182.201.122, and I'm saying that this VPN has to be established from the WAN interface of ASA. I'm saying the VPN has to be established from WAN interface of the ASA firewall. Say next. Now it is asking you what is your local network and what is the remote network. So local network is 192.168.20.0 and remote network will be 192.168.10.0, the network which is connected on Storm Shield. So we'll have to define that. So I'm creating an object for the remote network. So let us call it as say Storm Shield LAN. So I'm calling it as Storm Shield LAN, and here I say 192.168.10.0 is the network. Subnet mask 255.255.255.0. So we have defined the local network on ASA and local network on the Storm Shield side. Say next. Now it is asking us what is the pre-shade key. So let me take the pre-shade key as ABC1234. Say next. And then it is saying, do you want to disable NAT for the VPN traffic? You should always enable this option. So traffic that is passing between your local network and the remote LAN network. Traffic that is passing between your LAN network and the remote LAN network. NATing should always be disabled for this traffic, right? So NATing is only for traffic from your local network to internet, not to your branch network, right? So you have to always enable this option, disable NATing between this VPN networks. Say next and finish. That's it. On the ASA firewall, you are done with the VPN configuration, site-to-site VPN, right? So once the configuration is done, just say apply. You don't have to write any security policies and all in the ASA firewall. Just go through the VPN configuration wizard, right? Your VPN is configured. Next, we'll have to do the same on the Storm Shield UTM also. So in Storm Shield UTM, we'll see how exactly we can define this VPN settings. So once you log into Storm Shield, under configuration, you have to go to VPN settings. Under configuration, go to VPN settings. So click on IPsec VPN. So click on IPsec VPN. And here in the IPsec VPN, you have site to site and also mobile user, right? So mobile user is a different configuration, so that we will discuss in the next session. So now we are configuring something called site to site, right? So site to site is between two different networks, right? So under site to site, we have to say enable a new policy. So add a new standard site to site tunnel. So here it is asking you what is your local network, what is a remote network, and what is a peer. Peer is again nothing but your public IP address of the remote side firewall, right? So local network is 192.168.10.0. So I'm selecting this network in. For the remote side network, right? So I don't have a object created. So let me create a network object. So let me call this as ASA LAN. And here I say 192.168.20.0/24 is the LAN network on ASA firewall. 192.168.20.0 is a LAN network on the ASA firewall. Say OK. So now I am saying traffic from 192.168.10.0 to 192.168.20.0 will be my VPN, but it has to be through the ASA firewall, right? So here, let us define the ASA IP address. So this is the peer IP 206.182.202.122. Right. Say next, and the pre-shared key. So the same pre-shared key has to be used on both the firewalls. So the pre-shared key we configured on ASA is ABC1234. So the same thing I am also defining it here on Storm Shield. Say next. So now it says traffic from 192.168.10.0 will be passing to 192.168.20.0 through this ASA firewall. Say finish. Can say apply and save, but do not activate right away because you still have a lot of changes to be done. First thing, enable the policy, right? So by default, when you create a new policy in Storm Shield, the policy will be in the off status. So you have to enable the policy. That's the first thing. And then if you look at the encryption method, it says Storm Shield is using something called strong encryption here, right? But we are not really sure what is strong encryption, what kind of encryption method will be used and all, right? So let us verify all those details, right? Because we also have to check not only the encryption methods and all, we should also be checking the SA lifetime and all. So we'll verify all those details, right? And then we will finally apply the settings. So let us go to encryption profiles. So here it says strong encryption means SA lifetime is going to be 21,600 seconds, which comes to 6 hours. And the default public and private keys will be of 2048 bit, right? And encryption method is going to be AES 256 and hash algorithm SHA-256, right? But ASA firewall does not support these methods, right? So in ASA firewall, the SA lifetime is different, right? It is 24 hours instead of 6 hours. And then the encryption method in ASA is AES 128 bit and SHA is SHA 160 bit. So this strong encryption parameters on the Storm Shield UTM are not matching with what is supported on the ASA firewall. So what we have to do is create some new profiles, for this encryption and hash methods, which will be suitable to ASA firewall, right? So let me create a new phase 1 profile first. I'm creating a new phase 1 profile. So let me call it as say ASA phase 1. So in the ASA phase 1 profile, I say my public and private keys should be 1024 bit long, right? And the SA lifetime should be 24 hours, which when you convert it into seconds will become 86,400 seconds, right? So 86,400 seconds is a uh, lifetime for 24 hours, right? And then coming to the encryption method, it is going to be AES 128 and SHA-160 bit, right? AES 128 and SHA-160 bit is going to be the encryption and the hash method for phase 1. Apply these changes and save them, but do not activate right now. We should also define a new profile for ASA phase 2. Let's call it as ASA phase 2. So you have to make sure that all the parameters are matching for both the devices, right? So on ASA phase 2, there is no PFS, right? And the lifetime is going to be 28,800 seconds. So it should be 8 hours. Yeah, 28,800 seconds is the lifetime for uh, phase 2, which is going to be 8 hours. Encryption and hash methods also have to be defined. So hash method is SHA-160 bit. Encryption is AES 128. Apply and save, but do not activate right away. So what we did now is we have created a phase 1 and phase 2 profile, which is suitable with ASA firewall, right? So once it is created, the next step, go to your peer section. So here, this is where you have the ASA firewall details and all given. But if you see this IKE profile or the phase 1 profile, by default, your Storm Shield is saying it is going to use strong encryption method. But strong encryption method is not having parameters which are suitable to ASA. So we'll change this and say, don't use strong encryption method, use ASA phase 1 method. Right. So for IKE, use ASA phase 1 method, apply, save, do not activate. Then go back to your site-to-site policies and see here the phase 2 details. So in the phase 2 details, you have to say, go with ASA phase 2. Now you can say apply and activate. So you have to define the parameters properly, right? So all the parameters should be matching on phase 1 and phase 2. If not, your VPN tunnels will not be established properly, right? So once it is done, once you have your VPN tunnel configurations done and you have applied the settings, then go back to your security policy. In the security policy, you have to write a new rule which permits this VPN traffic. So here I say traffic from 192.168.10.0 to 192.168.20.0. Right, so here traffic from 192.168.10.0 to 192.168.20.0 has to be permitted. And in the same way, I also want traffic from 192.168.20.0 to 192.168.10.0 to be permitted. So my LAN network should be able to communicate with the LAN network on ASA firewall, and at the same time, LAN network systems on the ASA should be able to communicate with my local network resources. Right? So save and apply the configurations. So once it is done, now from my LAN computer, which is 192.168.10.10, I'll try to access 192.168.20.10. Okay, so I'm trying to reach 192.168.10.10. Sorry, 192.168.20.10 from 10.10. So give the password. So I'm trying to take a remote desktop of that system. So as you see, once I give the password for the user account, my remote desktop session is successful. I am able to connect. Okay, so from 10.10, I'm able to access 20.10. I'm able to take a remote desktop of it. Right? And this communication is all passing through your VPN. Right? So even though both the networks are not connected directly, right, through your existing internet connectivity, by creating this site-to-site VPN, you'll be able to securely access the resources between these two networks. Is it clear how site-to-site VPN works and how we can do the configuration? Now let us say your requirement is not to communicate between two different networks, right? Let us say you want your what do we say, your employee, right? You want your employee to connect to the office network, right, from their home and access all the resources. So in such condition, uh, can we ask employee to purchase a firewall, take up a public IP address from the ISP and all, so that we can configure a VPN? So that would not be possible, right? So we cannot ask the employee, right, to purchase a firewall and all, right? So in such condition, there is a different kind of VPN that we use, which is called IPsec remote access VPN. You have something called IPsec remote access VPN, right? So the only difference is, in case of IPsec remote access VPN, you will not have the second firewall. So you have your office network. Right? So you have your office network, your firewall or your router, your gateway device is connecting to internet. And when user is trying to reach your organization network from their home, because on user home you don't have a dedicated firewall and all this, here you are going to install a VPN client software, right? So you are going to install a VPN client software. So once the VPN client software is installed on the user computer, and provided user has access to internet from their home network, this VPN client software will initiate a request to your firewall asking for VPN connectivity. The VPN client software will connect to your firewall for VPN client. Now here there is a challenge to your firewall. In case of site-to-site VPN, In the Hyderabad firewall, you are defining what is the IP address of Delhi firewall. In Delhi firewall, you are defining the IP address of Hyderabad firewall. So they know from which IP address the VPN request will be coming in, and from which IP address, if the VPN request is there, you have to accept. But here, when you speak about user trying to connect from their home, there is no detail about what is the IP address. So we will not be able to tell the firewall you will be receiving a VPN request from exactly this IP address, because IP addresses keep changing, right? So there, what we do, instead of depending on IP address for the identification, when a VPN client is trying to connect to the firewall, right, we will ask the firewall to perform user authentication. Right, we'll ask the firewall to perform user authentication, right? So firewall will ask what is the user ID and the password. So once the user ID and password is verified, if that user ID and password is correct, then firewall will accept and permit access to the resources through VPN, right? So your firewall will permit access to the resources via VPN. And at the same time, your firewall will also assign a IP address. Firewall will also assign an IP address to the VPN client. Because if you see here in phase 2, what is happening? We are telling the firewall, you should enable VPN connections only for traffic coming from 10.0 network to 20.0 network. So we are defining which two networks or which two subnets will participate in the VPN. We are defining this in the site-to-site connections. But here, when it comes to the remote access connection, now let's say my LAN network is something like 192.168.20.0 network. So when we are configuring VPN, we should also tell the firewall what is the remote network, what is the network on the other end, right? So the problem here is when user is connecting from their home, this user computer can have any IP address which we are not aware of, right? So we don't know what is the IP address on the user computer. So to make things simple, what firewall does, once the user authentication is successful, firewall will assign an IP address to this user computer, right? So you can define some IP address which is uh, in a different subnet. It should not be in the same subnet as a LAN network. It should be a different subnet. So once the IP address details are defined, then firewall will assign this IP address here, right? Firewall will assign IP address to the user computer. And from that IP address, communication to 192.168.20.0, which is your LAN network, will be permitted, right? So it's simple like this. Let's say you have defined some IP address range as 192.168.30 dot something. Let's say 30.5 is IP address given to the user computer, right? So then firewall can say if request is coming from 192.168.30.5 to 192.168.20.0, it should be accepted. Right? So things will be easy for the firewall also on what kind of traffic has to be permitted and what should not be permitted. So the main difference here is because you do not have a static IP address on the user computer, you'll not be able to define that on the remote access VPN. So you go with user authentication. And the second thing, once the user authentication is successful, you're going to assign an IP address to the user computer so that from this IP address, whatever is assigned to the user computer, you will allow access to the LAN network via VPN. Right? So these changes have to be uh, taken care of when you are going with IPsec remote access VPN, or you can also just call it as remote access VPN, right? So IPsec remote access VPN or remote access VPN, both are one and the same, right? So two different names, right? So let us see how we can do the configuration for this IPsec remote access VPN. I go to wizard, right? VPN wizard, right? I'm going to the wizard, VPN wizard, IPsec remote access VPN wizard, right? IPsec remote access VPN wizard, right? So once I'm going into the IPsec remote access VPN wizard, I have to start the configuration. So let's say click on next, right? So it is asking you whether do you want to configure or do you want to use IPsec VPNs using the Cisco VPN client, right? Do you want to use it via Cisco VPN client or do you want to use the Microsoft inbuilt VPN client, right, in the operating system? So I'll say I'll go with the Cisco VPN client itself. Say next. Then it is asking you what will be the pre-shared key. So let me say I give the pre-shared key ABC1234. So I'm giving the pre-shared key ABC1234. And then it is asking you what should be the VPN name. What should be the name of your VPN? So let me call it as remote VPN. So I'm giving it a name as remote VPN. So this name has to be defined in the VPN client software. So whatever we are installing on the user computer. So on the user computer in the VPN client software, we have to define the VPN name as remote VPN. And then we have to mention the pre-shared key as ABC1234, same as what we have defined in the firewall settings. Say next. Then it is asking you like, how would you perform authentication? Will you go with the local database or a server? I say I'll go with a local database. So I'll try to create some user accounts locally on the firewall itself for the VPN. So I'm giving a username Zoom. Let's say I'll give a password Zoom. So I've created some user account and defined some password. Say next. And as I said, after authentication, your firewall has to assign a IP address to the user computer, right? So here you have to define the pool of IPs which will be used for assigning the IP there. So let me define a VPN pool. So starting IP, I'll take it as 192.168, say 30.10 to ending IP 192.168.30.20. So I'm taking this IP address. So I'm telling the firewall you can assign any IP address in 192.168.30.10 to 192.168.30.20 range for the VPN users. Okay, and then subnet mask, I'll say 255, 255, 255, 0. Say okay. Now, if you have some local DNS servers in the office, you can define those servers. If you don't have any servers, you can skip that. It's not mandatory, right? And then you have to say which network should be accessible to the end user after connecting to VPN. So here we say 192.168.20.0 network should be accessible to the end user. Right? 192.168.20.0 network should be accessible to the end user after VPN. Say next and finish. Your remote access VPN configurations is done. Right? Your remote access VPN configuration is done. Now, how do we connect to the remote access VPN? So as I said, for us to connect to the remote access VPN, we will need a VPN client to be installed here, right? So let us use this VPN client. So let me just start this external mission. So once I log into this external mission, I'll be able to use a remote access VPN client and connect to the firewall. So on the external mission, you'll have to have this Cisco VPN client software, right? So in the Cisco VPN client software, we define a new VPN profile, right? So connection entry name can be anything, right? So I'll just call it as office. And you have to give the host. Host is nothing but your uh, IP address of the firewall, right? IP address of the firewall where VPN is available. So I say 206.182.202.122 is the IP address of the firewall. So that's the public IP of firewall. So my VPN client software is going to initiate a VPN request to this public IP address, right? And then in the name, we have to give the VPN tunnel name, not the user ID. So remote VPN is the VPN tunnel name we have configured. So I'm giving the VPN tunnel name. And in the password, we have to give the pre-shared key, which is ABC1234. So confirm the password, that is confirm the pre-shared key. ABC1234 is the pre-shared key, what we have given. Save the configurations, right? Now here, if I check with my IP address, I have an IP address 206.182.200.123, right? So this is the IP address on my external computer, right? So let me connect to the VPN. So as you see, once I initiate a request to connect with the VPN, it is asking me what is the username and password, right? So username we have created is Zoom, password is Zoom for this VPN user account. Say okay. It will try to establish the VPN, and once VPN is established, as you see, that VPN client software will automatically minimize. And now if I check with the IP address on my computer, see earlier I was not having this IP address 192.168.30.10, but now I got this IP address assigned, right? I also have my public IP, but I also have another IP address 192.168.30.10 assigned here. And if you recollect, 192.168.30.10 to 192.168.30.20 So this is the pool of IP addresses what we have defined in the VPN, right? So we said that these IP addresses have to be given for the VPN users, right? So I got an IP address. So now let's say I want to connect to the office network computer. So let me say I want to reach 192.168.20.10. So as you see, it's asking me for password. So once I provide the password, I'll be able to connect to the remote desktop. Okay, so from my internet computer, I'm able to reach uh, my LAN network resources, right, through VPN. And for this VPN, before firewall has permitted me to connect to the network, right? It is checking with the user credentials, right? Only after successful verification, firewall is permitting us to access the local network resources there, right? So when people are working from remote locations, people working from home and all, right? They use this kind of VPNs, right? Between your office to your branch office or your office to your client office, you go with site to site VPN, right? Between user home network and office, you go with remote access VPN. Is it clear where exactly we use remote access VPN and where do we use site to site VPN? So these are like the two different type of VPN configurations in IPsec technology, right? So IPsec has two different type of VPNs, site-to-site VPN and remote access VPN. So these are the two different types. Now, not only IPsec, we are also using something called SSL VPN, right? We are also using something called SSL VPN. SSL VPN is also for remote access connectivity itself, right? So that's again a different concept, right? So we'll discuss how exactly this remote access, sorry, the SSL VPN would work in the next session. Chandu, you don't need Citrix and all for this VPN client. Okay, so this is how you have two different type of IPsec VPN configurations. Okay. So in the next session tomorrow, we'll see the SSL VPN configuration. And then we'll also see how exactly you can try to monitor the networks and all. Is that clear? Yeah. So with this, I end the session for today. So we'll continue tomorrow with SSL VPN. Thank you all.